Yesterday what we have done now, from there we are going to continue as addition of sections. So let me take one question here. So what is the question says means y equal to a sin omega t plus b cos omega t they given. We need to calculate net amplitude it seems. So in the question they given, one is nothing but function of sine they given, another is function of cos they given. So to add SHMs, basically we have to convert into one function. So what I'm writing means here y equal to a sin omega t we can write it, cos omega t we can write like this, plus b sin omega t plus 90 we can write it. Sin omega t plus 90 we can write it. So if you observe here, no, a net if you want to calculate, they're asking the question a net only. A net value how can you write? Parallelogram of vectors, under root of a square plus b square plus 2ab. Phase difference between these two is nothing but one is omega t a, another is nothing but omega t plus 90. So phase difference is how much? 90 degrees we got it here. So what you can write it here? Cos 90. Cos 90 is how much here? 0. Therefore net amplitude what we get it means under root of a square plus b square, which they asked in question only, this much only they asked here. For example, if you want to calculate tan alpha here, tan alpha how can you calculate here? So directly we can calculate, we'll got this is like a net na. So this is nothing but what here? Alpha. So tan alpha can be written as what? B by a. Alpha can be written as what here? Tan inverse of b by a we can write it. Therefore resultant equation how can you write it? Y equal to a net, right? A net sin omega t plus or minus alpha. So here resultant is leading with the a, no? So plus alpha only we can write it. Y equal to a net value how much we are having? Under root of a square plus b square sin omega t plus alpha. Alpha value how much I am having here? Tan inverse of b by a we are having here. This is the answer for this question which they gave here, but little simple question it is, direct question. Next question what is they are asking means, in next question they are asking like this. Y equal to 3 sin omega t plus 30 degrees plus 3 sin omega t plus 120 degrees they given here. So what we can write it here? Phi value if you check now, 120 minus 30 is how much? 90. Therefore phi equal to how much here? 90 we can write it. Okay. A net if you want to calculate, what will get it? Under root of a square plus b square, because 2ab cos 90 is 0, no? As we saw earlier. So a square is how much? 3, b square is how much? 3. 3 square plus 3 square. 3 square plus 3 square nothing but 3 root 2 which we will get it here. If I take 3 outside. Tan alpha we need to check. Tan alpha equal to what will get it here? So if this is 3 means other one will also 3. What angle they are leading or lagging means 90 degrees. A net will get here. How much A net value? 3 root 2. So this angle is how much here? We need to calculate alpha. Tan alpha. Tan alpha can be written as what here? Opposite by adjacent. 3 by 3. 3 will get cancelled. 1. Therefore tan alpha equal to what will get it here? 45 degrees. Tan alpha equal to tan 45 we can write it here. Therefore alpha equal to what we can write here? Pi by 4 we can write it. 45 or 45 also fine. So tan alpha equal to how much we got it? We just written here 3 by 3, that's nothing but tan 45. Fine. Therefore y can be written as what here? A net sin omega t plus alpha. A net value is how much? 3 root 2 sin omega t, as we did in last lecture. Sin omega t plus 30 degrees is there. We have to consider total phase of small one, plus 30 degrees plus 45 degrees we have to write it here. Therefore if you observe here now, y equal to 3 root 2 sin omega t plus 30 plus 45 is nothing but what we can write here? 75 degrees. This is the answer for this question here. So if anything is cos is there, we need to convert into sine, and we have to check about the phase angles also carefully. Give you. So next question they given like y equal to 3 sin omega t plus 60 degrees minus 3 sin omega t they given here. We need to solve this question. Earlier questions what they used to give, in between the functions we used to have plus symbol only, but we are having a negative symbol. We need to remove that negative symbol. If you want to remove that negative symbol now here, so what we need to do here? So we just have to do like this. Write down that equation like rewrite 3 sin omega t plus 60. This minus is there, that minus function I can write like this. 3 sine omega t plus 180. Omega t plus 180 means that's will come in third quadrant. Third quadrant sign will be sine only, but it is negative. That's why you can write like omega t plus sine 180. You can write it here. Therefore, phi value if you check now, 180 minus 60, nothing but how much phi value? Phase difference 120 degrees. We'll get it here. So A net if you want to calculate, no, A net can be written as what here? Under root of 3 square. 3 square is plus 3 square. Other one also 3 square plus 2 into 3 into 3 into cos 120. Cos 120 is how much? Minus 1 by 2. So what will happen? These two will get cancelled. A net can be written as what here? Under root of 3 square is nothing but 9. 3 square is nothing but 9. 3 3 is 9. But here one negative sign is there. We have to remember that. Minus 9. Minus 9 plus 9 will get cancelled here. Therefore square root of 9 will be again what we are getting here? A net equal to 3 we got it here. This is net amplitude which we observed here. Net amplitude of the given equation which we got it here. Now what we need to do here means we need to calculate tan alpha. Tan alpha earlier what we used to write? B sin phi divided by A plus B cos phi we used to write here. Therefore tan alpha equal to B value how much we are having? 3, right? So 3 sin 120 divided by 3 plus 3 cos 120. Cos 120. Therefore tan alpha can be written as what here? 3 into sin 120 will get as root 3 by 2. Root 3 by 2 divided by 3 minus 3 by 2. 3 minus 3 by 2 will get as 3 by 2 only. Therefore tan alpha equal to 3 root 3 by 2 divided by 3 by 2. 2 2 will get cancelled. 3 3 will get cancelled. Tan alpha equal to how much will get it here? Root 3 we get it. Therefore alpha equal to what will get? Tan 60 degrees. Root 3 value 60 degrees which we got it here. This is alpha value we got it here. Then how can you write y net here? Y net equal to A net sin omega t plus alpha we used to write generally. Now A net values we need to write. Y equal to A net is how much we got it? 3 sin omega t. Omega t least one total phase what we are having here? Omega t least one phase nothing but just omega t, right here? Yes. Least one phase is omega t plus 60. We converted this thing, no? Omega t plus 60 plus 180. Among these two, whose phase is least? No, 160, no? So plus 60. And one more thing what we are having? Plus 60. Therefore, what will get it? Y net equal to what we are having? 3 sin omega t plus 120 we are having here. This is the final equation of addition of SHM. So all variants we learned here. Next what we have to write it means. So what are the points to remember to do this SHM utility control? So for what we have learned now, let me discuss here. So what are the points to remember to add the SHMs means? First, both terms should be sine function we have to remember. Both terms should be sine function. Second point what you have to remember means there should be a plus sign in between two terms. In last question it was negative sign, we converted into positive sign. Next, third one what we are going to discuss means the phase should be written in such a way that the phase should be written in such a way that omega t should cancel out while taking phase difference. Means omega 1 value, omega t value should be same. Then only omega t values will get cancelled. Next, A1 always should select whose phase difference is smaller. A1 always should select whose phase is smaller. Whose phase is smaller, which we can discuss here. Next point, what they're giving here means, for finding in it, what we need to do, we have to treat a1 and a2 like a vectors. So that's what we have to mention here. For finding net amplitude, treat a1 and a2 like two vectors and solve by using parallelogram vector, parallelogram law of vectors. Therefore, a net can be written as what here? A net can be written as a1 square plus a2 square plus 2a1 a2 cos phi. So then what we need to write? Final SHM equation can be written as what? Final SHM equation can be written as y equal to a net sin omega t plus or minus alpha, we can write it. So this omega t plus alpha, omega t we are choosing, no? That omega t is nothing but what here? Phase of a1 we are going to take here, phase of a1. Finally, how to calculate that alpha means tan alpha equal to what we are having here? a2 sin alpha divided by a1 plus a2 cos alpha. The same thing we can discuss in terms of what? a2 sin phi divided by cos phi nana. So this can be discussed in terms of a and b also. We will get the same answer here. This slide we are going to discuss about Young's double slit experiment. We are going to discuss about bit introduction about that. So in first case what I am taking means I am taking one cardboard here. We made one small slit here. Small slit we made it here. And what we are placing is we are placing somewhere here light source. Light source which can emit the light here. Source. In front of that what we place means here one screen we placed. One big screen we placed here. So what we are able to observe means we are able to observe due to that screen whatever the light passing here, we can able to observe one spectrum here, one patch we are going to apply on the screen. This is called what here? Slit. So whatever the light rays passing here through the slits now, so that will make the one patch on the screen which we can observe due to what? Single slit. In next case what we did means we took a cardboard. For that cardboard what we made means we made two slits here. This is like I am naming like S1, this is like I am naming like S2, and I am placing source here. So whatever the light passing through here, no. So if one slit is there, how many patches going to observe here? One patch, one bright patch we are going to observe here. But if you observe, no, if I take two slits here, no, two slits. So on the screen how many bright patches or dark patches will happen? We have to observe this. So this is a screen now. On screen what will happen means in center one bright patch will be occurring due to that. So after that one dark, again what will happen? One bright happening, again dark, again bright. Similarly downway also, again bright, again dark, bright. Like these consecutives, black and white are bright patch, dark patches are forming here. So which I shaded, no, this I am considering like bright patch here. Bright patch. Remaining I am leaving like dark patch, this thing. Dark patch. So generally if you observe, you know, in first task what we did? We made one slit here. Due to one slit, how many patches observed? One patch we observed. So we made two slits. How many patches we assumed to get here? Two patches we assumed here. Two patches assumed. But how many patches, bright patches we got it here? Number of bright patches is more than the number of slits which we observed here. That's why what will happen means, so Young's double slit will be happen here. Interference will be happen. Due to interference what will be happen? Consecutive dark patches and bright patches will be observed here. So how to get the maximum means, for example, how to get maximum means, I'm taking slits like this, one dimensions. These are my slits and this is my screen. Slits are S1 and S2. Distance between the slits I'm taking like D here, and from the center of the slits to this point is O. So where does maximum will happen means at O will be happening maximum. So whatever the light rays passing through the S1 and S2 will go and incident on what? O. So generally if you observe here, no, S1O almost equal to what here? S2O. Therefore S1O minus S2O difference is how much here? 0. Therefore path difference is how much means 0. That is called what we can tell here? Maxima we can tell here. Maxima in that where central one is forming now here, that is called central maxima you can name here. So as earlier we have studied about the what? Maximum minima. Now we have to know maximum minimum basics here. So maxima means what we know? Maxima. Maxima means bright patch. Whatever the delta x value means, delta x equals to n lambda we learned. N value should from where? 1, 2, 3. 0, 1, 2, 3 we learned here. And minima we learned in different diffraction, interference, sorry. Minima we learned in last class. Minima. In minima where we'll get it? Delta x equal to what we got it? 2n minus 1 into lambda by 2, where n value should start from 1, 2, 3 we told here. These values we need to remember to solve the YDSC. Now let me get into main concept. From there only they will ask you CBSC and CET, all the numericals also will come from there, next part only. So here what we are going to discuss here? YDSC we are going to discuss here. Main YDSC. Let me change the slide. Here what they are asking means YDSC we are going to discuss, right? YDSC. See, we are taking two slits as usual earlier. Like these two slits we took and one screen we took here. Screen. The distance between slit and screen is called capital D, which I am choosing. The distance between two slits is nothing but small d, which I am choosing here. Okay. Now what we are placing means somewhere here we are placing one source. So this point is called what we named here? O, and O is called what? CM. CM stands for what? Central maximum, which I named. So one ray is passing through this and going like this. Another ray is passing through S2 here. This is S1, this is S2. What will happen? That ray will be going and passing here. Let us assume at P some maxima or minima is going to happen. Okay. Now if you observe here, no, S1P, from here this point to this point is called what? S1 free. From this point to this point is called what here? S2P you can tell here. If you observe now who is traveling more means it's very clear S2P is traveling more. How much distance means? You have to drop a perpendicular here like this. So this can be called as what, Nana? Delta x. That much extra distance is going to travel here. Now if this angle is theta, what will happen? If this angle is theta and I am taking one more here like this, and this also is theta. If I take now, this will be taken as theta. And name this is like P, na? So this point I am naming like Q, and this point S2 already we named. This point I am naming like R. I am sending one line here also like this. From where? From R to P. If this angle is theta, if this angle is theta, this angle can be taken as what here? Theta. Corresponding angle we can take here. Now we need to check path difference. Path difference means what we need to check? S2P total. S2P total distance minus S1P total distance equal to what we can write it here? Delta x we can write it here. So S2P from where we have to calculate this means from triangle S1 S2Q I am taking here. From S1 S2Q, this triangle, this fellow, this fellow, this fellow. What we need to calculate? Sin theta. Sin theta equal to what we will get it here? Opposite is what? Delta x. Delta x by small d we got it here. Next another triangle we are taking from triangle RPO. From triangle RPO what we can take it? This is R, this is P, this is O. So from here what we can write it here? And I am choosing from P to O distance is nothing but Y I am choosing here. So what we can write it here? Tan theta equal to what we can write it here? Y by capital D we can write it. So we know that if angle between these rays is small, no? For small angles, tan theta always should be equal to what here? Sin theta. From sandwich theorem mathematics we know that. So means tan theta equal to sin theta means y by d value should be equal to what here? Delta x by d. Therefore y equal to what we get it here, delta x into capital D by small d, we got it. This is the one of the important formula which we have to remember here. The same equation we can use for what, maxima and minima also we can use here. Let me go to next slide. Position of bright fringe, position of dark fringe. First we are going to discuss bright fringe. Bright fringe is nothing but what here, maxima. For maxima, you know delta x value, delta x equal to what we get for maxima, n lambda we learned here. Therefore y equal to what we are having, so delta x into delta x d by d, na? Delta, in the place of delta x what we need to substitute n lambda, so therefore y equal to n lambda d by d. So maximum value should, n value should be start from where for maxima, n equal to 0, 1, 2, 3 and so on, na? So we can substitute 0 first. So this is called central maxima, that is nothing but 0 into lambda d by d, that's nothing but 0, we got it. Central maxima value is 0. First bright fringe means what we need to substitute 1 lambda d by d, that's nothing but lambda d by d, which we got it here. Next what we are going to discuss, second bright fringe means how much we'll get it here, 2 lambda d by d, which we are going to discuss here. So that's nothing but 2 lambda d by d only, we'll get it here. Next, dark fringe we are going to discuss. Dark fringe. For bright fringe, mainly we are going to discuss this about this formula only. We need to remember about this formula. Next, we are going to discuss about what here? Dark fringe. Dark fringe is nothing but minima. Minima values we learned that delta x equal to what we learned? 2n minus 1 lambda by 2. We studied that. Therefore, we know that y equal to what we learned here? Delta x d by small d. Therefore, y equal to delta x value, how much we are having here? 2n minus 1 lambda d by 2d, will get it here. And n value starts from n equal to 1, 2, 3 and so on. We studied in last class here. Therefore, this is for nth dark fringe. If you want to write for first dark, no? So if you substitute in the place of n 1, no? 2 into 1 minus 1 into lambda d by 2d. 2 1s are 2, 2 minus 1 is nothing but 1. That's nothing but lambda d by, this is small d, no? Lambda d by 2d, we can write it. For example, y 2d, if I want to write now second dark fringe, 2 into, in the place of n we are going to substitute 2, 2 minus 1 lambda d by small d, that's nothing but 2 to the 4, 4 minus 1 is nothing but 3, 3 lambda d by 2d, which we got it here. This is nothing but dark patch, white patch, which we have discussed here. Now we are going to discuss about the difference between these two, and the difference between these two we are going to discuss here. That is called what we are going to discuss. We are going to discuss about what? Fringe width. Fringe width. What is meant by fringe width means the distance between two successive bright or two successive dark fringes is called fringe width. Is called fringe width. So the difference between two bright fringes, let me calculate how much we will get it. Y2 bright fringe minus y1 dark fringe is equal to how much we will get it? 2 lambda d by d minus lambda d by d will get it. So that's nothing but how much we will get it? 2 lambda d by 2 minus 1 is nothing but lambda 1, no? Lambda d by we got it. So that symbol is generally given as what? Beta here. Beta can be written as what here? Lambda d by d. So and next one what we can check, if we can check with the dark also, y2d minus y1d. So y2d is how much? 3 lambda d by 2d minus 2 lambda minus 1 lambda minus 1 lambda d by d. So again what will get it here? 2 lambda d by 2d we got it. This fellow will get cancelled. Therefore beta equal to what we can write it? Lambda d by d. You can check for either dark or bright, you will get same answer here. That is called what here? Fringe width we can tell here. So fringe width is depends on what means, it's directly fringe width directly proportional to what here? Lambda, and it's inversely proportional to what here? Distance between the slits. Distance between the slits is nothing but we can tell as small d, which we can tell here. And in this summary, bright fringe is one point which you have to remember, and bright fringe we are going to discuss. This is called what? fringe width, fringe width is 1 point, and bright fringe what we have to discuss, y nth bright is can be written as what here, n lambda d by small d. Y nth dark we are going to discuss here what, 2n minus 1 lambda d by 2d. These formulas we need to remember to solve the numericals. Along with these two we are going to discuss about what, that fringe width also we have to remember these formulas also. Discuss in this slide numericals based on this. What are the numericals means? Let me take one, find the separation between the 7th maxima and 11th minima on same side of the central maxima they are telling. The data they given, small d value how much, capital D value how much, lambda value how much they given here. So if you choose here screen here, no, like this, here central maxima will get it here. Central maxima, after central maxima, first maxima, third maxima, second, third, like that will get it. Somewhere here what we are having here, 7th maxima we are having. So after that somewhere here what we get here, 11th minima. So the distance between 11th minima and 7th maxima we need to calculate. So means from here to here what we can take it here, y 7th bright fringe. From here to here what we need to calculate, y 11th dark fringe. If I subtract 11 minus 7, no, dark minus bright, no, we will get that distance. So what we can write it here means, y 7th bright fringe. 7th bright fringe means what we can write it, n lambda d by d, na? N value is how much, 7 lambda d by d we can write it. Y 11th dark fringe. Dark fringe formula what is what? 2n minus 1 lambda d by 2d. Therefore 2n minus 1, 2 into 11 minus 1 lambda d divided by 2d. Therefore 11 2 is 22. 22 minus 1 is nothing but 21. 21 by 2 into lambda d by 2 we can write it. Now we need to subtract these two, will get the answer. Y 11d minus y 7th bright is equal to, what will get it here, lambda d by d common from these two. So y 11d value 21 by 2 minus 7, if I take common is 11d by d. So 21 minus 7 is nothing but how much, Nana? 21 minus 14 divided by 2 lambda d by d. That's nothing but what will get it here, 7 by 2 times the lambda d by d. So let me substitute the values which they given here. 7 by 2 into lambda value how much they given here, 5000 angstroms. 5000 into 10 raised to minus 10 which they given here, into one more is what, capital D. Capital D value they given like 0.5 meters, divided by small d we have to write it here. Small d value how much will they given here, 1 millimeter they given here. So after substitution what will get, it means these all values comes out to be 0.87 millimeters which will get it here. So here they told same sides of central maximum. Let me discuss one more question, similar question. In that next question what they are going to tell me is, let me change the slide here. They are asking, find the separation between second maxima and third maxima on opposite side of central maxima. Small d value they given like again 1 millimeter, capital D value they given like 0.5 meter, and lambda value they given like 5000 angstroms which they given here. Same data they given here. So for this data we need to check. Now you have to understand the question clearly. They given same side or opposite side means they given opposite side. Then how to draw that spectrum means, so this is the screen which we have to take here. Here we are having central maxima. So if I choose here this side, which maxima? Second maxima, no? Second bright fringe. This side what will get it here? Third bright fringe. Opposite side we have to choose. This is nothing but y2b. This is nothing but y3b. Distance between these two we need to calculate, means what we need to do? We need to calculate this total distance. We need to add y2b plus y3b. So means you know that y nth bright fringe is nothing but what we can write it n lambda d by small d. Therefore you need to calculate this total distance now. y2b plus y3b is equal to, we need to calculate y2b means in the place of n what we need to substitute 2 lambda d by d plus in the place of 3 lambda d by d. Therefore what will get it here, 5 lambda d by d will get it 5 lambda d by d. Therefore how much we are going to substitute, 5 lambda value given like angstroms, 5000 into 10 raised to minus 10 into capital D value 5 into 0.5 meters, 0.5 they given, divided by how much we are having, small d. Small d value how much we are having here, small d equal to 1 millimeter, 10 raised to minus 3. So if we solve these all things now, this answer comes out to be how much, 12.5 micrometers. Means the distance between second maxima and third maxima on opposite side of CM, on opposite side of central maxima is 12.5 micrometers, which we can mention here.